Climate change is a real-life problem and it's our responsibility to fix it. Here at Newcastle University TEDx Countdown, we're going to discuss how the past meets the present and the implications going forward. Together we can alter the course of global warming and envision a greener future. Imagine, if you will, an algal world, a green revolution, if you will, but not using terrestrial plants, instead looking at other opportunities such as the marine and freshwater environment, macro and micro algae. The luscious green utopia we have on planet Earth was not always like this. In fact, it started as a hot, fiery ball of magma. So the real question is, how did we get from that to where we are now? And the answer starts with an ice age. "444 million years ago, the first ice age occurred. So the question is, how did we get from fire to ice? And the answer is algae. The carbon dioxide in the atmosphere gave rise to photosynthetic evolution in organisms in the ocean. And as you would expect, the oxygen released gave rise to respiratory organisms as we would know today. However, 85% of these organisms died in a very short time of the Paleozoic age. Why did this ice age occur? Well, algae became so photosynthetically efficient that it actually removed so much carbon dioxide from the atmosphere that it gave rise to the first ice age. It dropped the CO2 levels below 200 parts per billion, which is a crucial factor for an ice age to develop. As we can see from the National Geographic statistics, this was the first mass extinction event during the Ordovician age. You may ask, why are we talking about crude oil? We're trying to move away from it. But it's important to understand how we've developed our society as we know it now in order to exhaust every option in developing a greener future. And there's been some fantastic work done at the ACROS Institute in Fukuoka, Japan, whereby incorporating terrestrial plants into architecture, giving us the rise of eco-architecture. However, how do we do more? How do we fully exploit the potential in these eco-architecture buildings? And the answer, once again, is algae. Over the last 20 years, photobioreactor systems to grow algae have come along leaps and bounds, and we're now looking at the possibility of algal culturing being developed into architecture. This isn't a new idea. It was actually done in Hamburg in 2017, and they had some great success developing algae for biofuels in the window panels. But how do we do more? How do we fully utilise the potential of these organisms in our green eco-architecture society? In order to answer this question, we first need to understand the tree of life and how algae is one of the most diverse groups of organisms on planet Earth. With the new research into algal biodiversity, what we're realising is algae can do a lot more. There's a lot more potential in these groups of organisms than we previously thought. All animals, as we know, fit in one singular branch of the phylogenetic tree. However, as we can see, algae have superior diversity and encompass a plethora of evolutionary aspects. What else, other than biofuel, can we do with algae to incorporate it into eco-architecture? And this was actually explored during the Living Architecture project. This EU collaborative effort involving Newcastle University aimed to incorporate algae into buildings by utilising them to dispose of wastewater through bioremediation, of which the product would be used to generate electricity. And we had great success with this. The algae effectively cleaned the water and provided the fuel source for the microbial fuel cells to in turn generate electricity to put back into the building. So while it's evident that we're making great strides into eco-architecture development and the incorporation of algae into infrastructure and industry, how can we, the general public, utilise the biodiversity that algae affords us in our everyday lives? What if I told you we already heavily rely on algal biodiversity in our everyday lives? In fact, up to 70% of the oxygen produced on planet Earth comes from the ocean. To put this into context, every other breath that you take came from algae. In addition to this, algae are one of the fastest growing plants on planet Earth, if not the fastest, some doubling every 24 hours in size. So it's really no surprise that the ocean holds up to 85% of photosynthetic life on planet Earth. So, other than giving us the ability to breathe and providing the entire base layer in the oceanic ecosystem, How else can we use algae in our daily life to better ourselves? We can do it by algal consumption. When we look at the components and products of algae, we can see some amazing health benefits and implications through the consumption of these species, one of which is astaxanthin. This is an antioxidant which is 5,000 times more powerful than vitamin C and 500 times more powerful than vitamin E, simply by eating the algae. Furthermore, we've seen some brand new research about reduced blood sugar levels and weight management through the consumption of algal polysaccharides and polyphenols, which have direct impacts on our health. In addition to this, seaweed is a rare major iodine source, of which consumption can have a plethora of immediate health impacts. Official advice from the Health Department of the European Union suggests that increased iodine intake can lead to a range of health implications, such as increased metabolic efficiency, increased thyroid function, cognitive development, skin and growth in children, and improved nervous system function. So while it's important to consider the role that algae has had in our past in developing the world where we are currently at, it's also important to look at the potential of algae going forward, whether that be incorporation into infrastructure or as a consumable on a daily basis. One thing's for certain, the world as we know it is not lost yet. However, if we continue on our current trajectory of climate change, it is inevitable. With current technology and research in the field, we can fully utilise the biodiversity of these organisms to provide an algal world and a green revolution.